we're on. Now, this is going to be on electrolysis. Okay, so some of us might not know some of this stuff because you may not have done it yet. All right, so I'm going to go very quickly through electrolysis. Electrolysis. Okay, first of all, what does it mean? It means electro means using electricity, and lysis is to split. So very simply, electrolysis is splitting up. It's only ionic compounds into their elements. Okay, and don't forget, I'm recording this, so you don't have to write any notes. But having said that, the recording runs out in a half hour, so I'll have to start another recording there. So electrolysis, it's to split up using compounds. Now, as you all know, I hope, that if you have an ionic compound, let's do a nice ionic compound here. I'm going to be very quick, by the way. Okay, these are positive and negative ions. Okay, so these are positive and these are negative. These ions cannot move. All right, and what we say is are they locked? This is a nice way to do it. In the exam, they're locked in the lattice. And because of that, they cannot move. And therefore, ions or charge, the charge on the ions, charge cannot flow. Okay, if charge cannot flow, it is a non-conductor. And that's why sodium chloride, or that's why solid ionic compounds do not conduct electricity. So this is why solid ionic compounds do not conduct electricity. They don't. Why not? Because the ions cannot move. They're locked in the lattice. Charge cannot flow, so it's a non-conductor. Now, there's two things we can do to make this a conductor, as you all know. We can do that, or we can do that. We can melt them, or we can dissolve them. If I melt, this is, for example, this is sodium chloride. Okay. And those of you that are good at chemistry, you would have known it's a group 1 and a group 7 because of the charges. So sodium is plus, chlorine is minus, or chloride is minus. So how do we get the ions to conduct electricity, or the compound to conduct? What we do is we melt it. Okay, there. And as I say, I'm going quick, eh? You can ask questions, obviously, or we dissolve it, but we just don't really have time for much else. Oops, something's gone wrong with the computer. So we're going to melt it, and if I melt it, what am I going to get? I'm going to get sodium ions. Whoops, what on earth is that? Hold on, something's gone weird in the matrix. Okay, I'm going to get what's that? What's going on now? This all I need. Okay, there you go. That's better, I think. All right, so if I melt this, I'll get sodium ions and chloride ions, as you all know. Now, the sodium ions will be positive, and the chloride ions will be negative. If I dissolve it, I'll get sodium ions and chloride ions again, won't I? All right, the sodium ions will be positive, and the chloride ions will be negative. Now, the only difference is in the solution, I'll also have water molecules because I'm dissolving it. So I'm just going to draw those as green little circles. So that's the main difference. If you dissolve, you add water. If you melt, you heat. Now, if I put 2 electrodes in here, there's one electrode, there's another electrode. Let's make them a bit thicker. Whoopsie daisy. There you go. That's pretty ugly, but there, you know what I mean. My my pen isn't doing great today. I don't know. It's weird. All right. So there, I'm going to put 2 electrodes in. This is the electrode connected to the positive. This is the negative. The one that's connected to the positive is called the anode. The one that's connected to the negative is called the cathode. Okay, I'm going to do the same over here. There you go. Forget about the quality of the diagram. Okay, it's just, I don't know what it is. It's just not good these days. It used to be much better than this. So this, again, is the anode for the right one. And this is the cathode for the right one, positive and negative. These anodes, by the way, are generally made out of either carbon or platinum. So we're going to just use carbon today. Okay, the type of carbon we use is graphite. Okay, so there's graphite and graphite. Now, what's going to happen? Well, the positive ions are going to go to the negative electrode, and the negative ions are going to go to the positive. And therefore, now we have a movement of ions. We have a movement of ions, and that is a current. Same here. All right, positive things will go to the negative, and the negative things will go to the positive. Okay, now the water molecule splits up here. So H2O will split up into H plus and OH minus. So the H pluses will also go to the cathode, this one, and the OH minuses go to the anode. So that makes the dissolved system, it's more complex. And why is it more complex? Because we have to look at the ions from the water. So the ions from water take part in the electrolysis. And that's a pain. Okay, so when we think of these, we must think of them right down the middle. Things we've melted and things we've dissolved. Because dissolved are more complex. And because they're more complex, we have to think about them more. So the first one, obviously, to do, I think, is the molten system. This one. Okay? Now, think of it like this. Think of, I'm going to draw a big cell here. I'm going to go over here. And like this. And this is the anode, isn't it? Why is it the anode? Because it's connected to the positive. And this one is the negative, and this one is the cathodes. So it goes down like that. I hate that noise. I'm going to have to turn it off soon. All right, and there you go. There is the cathode. And let's pretend all we've got, we're using only sodium chloride liquid, no water. And this is molten sodium chloride. We've just melted it. It takes a lot to melt it, 808 degrees C, but we can melt it. So we've melted our sodium chloride. Now, what ions do we have in solution? Well, we have sodium ions. There's one. And there's a chloride ion. There's another one. And we have a sodium ion. There's one. And a chloride ion. There's another one. Let's keep it like that for now. Now, what's going to move to where? Well, obviously, the sodium ions are going to move to there, to the cathode. There they go. And the chloride ions are going to move to the anode. And there they go. Now, when the chloride ions get there, let's do a different color. Let's pretend they turn green. Oh, it's gone red, apparently. All right, let's make them green. Green, I think. When the chloride ions get there, this electron jumps off and it goes onto the anode. And this one here, the other chloride ion, its electron jumps off and goes onto the anode. And therefore, what's left on the anode? Well, 2 electrons. Now, these electrons will be pushed around the system like that. And they will eventually end up on here, on the cathode. All right, so the chloride ions lose electrons here. So we can write that in a chemical equation. And the way we write that is Cl minus becomes a chlorine atom plus an electron. It's split apart, okay? Now this happens to another one. A chloride ion splits apart to a chlorine atom and an electron. And then these 2 atoms here will bond together to make a Cl2 molecule. So the overall equation we say 2Cl gives Cl2 plus 2 electrons. And chlorine gas bubbles off here. Okay, right, let me have 2 seconds break. Does everyone understand? Are we all good? Let me have a drink of water. I'll just wait 2 seconds. All right, I'm assuming. Can you push the thing? What's it called? The gosh, what's it called? I can't remember what it's called. The what am I trying to say? Oh, there you go. I found it. The stickers or whatever they're called. All right, there. Woohoo! You see, if you understand, you can push those. Okay. Yeah. Thanks, Amy. Excellent stuff. Oh, well done. Ordney, what's wrong? You've raised a hand. You can put your microphone on. Oh, you're okay. Okay, good. All right. So that's what happens there. All right. So you get bubbles of chlorine. And at the other one, well, the sodium ions reach here. And these guys, Na plus, these are Na plus, and they're going to take the electrons from the cathodes. Okay, so electrons are ripped off at the anode. They go around the what's called, this part is called the external circuit. Okay, and this part is known as the internal circuit. Okay, so electrons are ripped off at the anode. They go around the external circuit and they end up on the cathode. And when they're taken off the cathode. And this continually happens. So literally electrons are doing this all the time. And that's what completes the circuit. All right, so as you can see, the currents, the definition of current, it's a funny definition, but I'm sure you all know it. The definition of current is the movement of charge. Okay, now in the external circuit, that's in the wires at the top up here. The charge carriers are electrons. They move around. But in the internal circuit, the charge carriers are ions. All right, and that's very important. Ions in the internal, electrons in the external. So that's what happens. Anywho, now we've got to draw the equation here, and the equation here is going to get, let me get a brighter color, is going to be Na, well, there's an Na plus, it's going to gain an electron, and it's going to form Na. That's it. All right, now on the left of these equations, you have something that is charged, and on the right, you have something that is neutral. Same as up here, charged, neutral. All right, so therefore we call these the equations of discharge. That means things are discharged. Now at the anode, and this gets a tiny bit complicated, but it's life, I'm afraid. At the anode, electrons are taken off you. Oxidation is loss of electrons. Okay, so at the anode, oxidation takes place because they lose electrons at the anode. At the cathode, they gain electrons. Reduction is gain. So at the cathode, they gain electrons. So what happens at the cathode? I hope I'm not getting this wrong way around. At the cathode, reduction takes place because they gain electrons. All right, so that's a bit of a big deal. Okay, so this is molten systems. This is what happens in molten systems. I don't want to go on. I'd love to give lots of examples, but that's not the point of these. These are just revision lessons. Okay, so this is molten systems. Now we've got to look at the more complex aqueous systems. Now these are more complicated. Why? Because they involve the ions from water. These involve the ions from water. Okay. Now, what are the ions from water? Well, whether you knew this or not, you're going to learn it now, I guess. Water, H2O, splits up into ions. It doesn't do it much, but it does it a little bit. It is a reversible reaction, and it splits up into H plus ions, aqueous, and, oops, my is lagging again, OH minus ions, aqueous. Now, let's electrolyze. What shall we electrolyze? Let's electrolyze sodium chloride aqueous. All right. Now, before, the one up here, we did sodium chloride liquid. But this one is aqueous, and that means it's got water. So what ions are around here? Well, let's put this down there. You've got sodium ions from the sodium. You've got chloride ions from the chloride. But you've also got hydrogen ions from the water. And you've also got OH minus ions from the water. Okay, so there's 4 ions to mess around with now. Now, if you can imagine the electrolysis now, there's the, what's the one on the left again? It's the anode, isn't it? Okay, this is the anode, I believe. And over here, let's pretend we've got the cathode. Now, what happens is, this is the cathode. What happens is, you've got Na plus ions, you've got Cl minus ions, you've got H plus ions from the water, and you've got OH minus ions from the water. So what that means is if it works, the Na plus ions are going to go to the cathode, but so are the H plus ions because they're both positive. The Cl minus is going to go to the anode, and so is the OH minus. Now, believe it or not, not both of these are discharged. Only one of them is discharged. And now we have to know rules. The rules only apply to, where are we? What color am I going to use? The rules only apply to aqueous solutions because these are the only ones where you have more than one ion going to the anode or the cathode. So this is the aqueous solution rules. And at the anode, it's very simple. If a halide present, it goes. And a halide is a group 7 ion, chloride, iodide, and bromide. Okay, so if there's one there, that goes. If not, the OH goes. If not, OH minus is discharged. Okay, now at the cathode, simpler rules. Cathode, the ion lower in the reactivity series. That's the one that goes there. Very simple. Okay, so let's use the rules. We've got going to the anode, we've got chloride and OH minus. Is one of them a halide? Yes. So that one goes. Simple as that. So at the anode, we're going to get Cl minus. If you remember, how does this discharge? 2Cl minus gives Cl2 plus 2 electrons. So we're going to get bubbles of chlorine given off here, like last time. Okay, minus there. All right, so there you go. That's the equation at the anode. At the cathode, it's much simpler. Sorry, I don't know what I'm saying. Right, now, hold on. Why is this taking so long? It's taking ages. All right, let's start again. Which one of these two, sodium or hydrogen, is lower in the series? It's hydrogen. So hydrogen, H plus, will gain an electron to form hydrogen gas. It will happen to 2 of them. You see the lag. I don't know if you can see the lagging. It's awful. Whoops. Here we go. Actually, that 2 shouldn't be there, should it? And then what happens is it happens both, and then these 2 hydrogens form the molecule. So the overall equation here is 2H plus 2 electrons gives me H2 gas. So what we get here, is it going to come? Yeah, there it goes. We're going to get bubbles of hydrogen here. Okay. Now, so the products of this electrolysis are chlorine and hydrogen. Oh, someone's put their microphone. Pearl, turn your microphone off. Pearl, for God's sake. All right, what's happened there? All right, so are we all good? We're all good so far? Anyone? Are we doing all right? Anyone want to put a hand up or anything weird? Nothing? All right, I'm going to do it then. Woohoo! There you go. What does this one do? I like this one. Hey, look at that. Okay, so there you go. So that's what happens here. Now, if you've got, what have we got? We've got sodium ions. We started off with sodium ions and chloride ions, Na plus and Cl minus ions. We had H plus and OH minus ions from the water. Now, which ones disappeared? Well, the chloride ions disappeared. All right, and the hydrogen ions disappeared. So what's left is sodium hydroxide. So sodium hydroxide is left. I hope that makes sense. Yes? Now, all right. Now let's have a look at a question or two, because I don't think this is I think this is the whole point of these. All right. So let me put a question or two up. I hope this is going to work. There we go. Is it going to work? It's taking. Oh, there we go. All right. So there is a question. All right. Now, while I put this in position, make it back to 100, or about 70. All right. What is the answer there? You read that and put your answers in the comments. Oops, it's gone. Move this up. Move this down. Make it bigger. What are the 2 answers there? Anyone at all? Anyone? Maybe you're answering and I just can't see because I don't know what it is. The internet seems awful these days. It never used to be this bad. Anyone want to answer? Either one. Everyone's chicken. Is that right? No one? Okay, well, you could easily be giving me answers, but I wouldn't know. Is that true? Put a thumbs up if you are writing an answer down, but it's just not coming through. No, you're just not giving answers. All right, do you understand the question, anyone? Just put this if you understand the question. C for Micah. Well, at least you're trying. Let's have a look. The electrolysis of copper sulfate using inert electrodes is shown. All right, which statement about reaction at an electrode is correct? Copper ions gain electrons at the negative electrode. Isn't that what happens? That looks like the answer to me. So what's going to happen? You've got one electrode, and then you've got another electrode, like that. Okay, even though that's awful, isn't it? Let me make that a bit bigger. What is this? Oh, I see, it's 75%. All Right, let's make this a bit bigger. All right, and then you've got copper ions in solution. So let's call this one the positive, and this one's the negative, like that. This is the positive. This is the negative. There's a copper ion. Now, which way will the copper ion go, Micah? To the cathodes or to the anodes? Which way would it go? Yeah, it will go to the cathode. So it's going to go to those. What's it going to do there? When it gets there, it's going to be copper 2 plus. What's it going to do when it gets there? Anyone? Doesn't have to be Micah. How many electrons? What will it do? Gain or lose them? Yeah, exactly. It gains 2 electrons, doesn't it? And it's going to form copper. Yes? So let's have a look at A. Copper ions gain electrons at the negative electrode. That looks good to me. Yeah? Does that make sense? Are we good? I think that's the answer, isn't it? Yes? All right, so that's the answer there. All right. Have a look at the next one. Which row describes the reactions during the electrolysis of dilute aqueous sodium chloride? Which one there? Which equation is right? Well, yeah, I think it might be actually. Maybe. Let's have a look. So, the best way to do it, if you don't understand it, is to draw it out. Okay, so I'm going to draw it out slowly because the pen is useless. All right, there we go. Oops, what the hell's going on? There it is. And I'm drawing it out. This looks awful because the pen is refusing, as they say. Right, so what ions do I have in aqueous sodium chloride? I've got sodium ions, and I've got chloride ions, and I've got OH minus ions, and I've got H plus ions. They're the things I have to play with. All right, now the sodium ions are going to go to the negative. The hydrogen ions are going to go to the negative. The chloride ions is going to a positive. Hold on, Amy, I'll come back to you in a minute. And the OH minus ion is going to go there. Yeah. So what's going to happen? What's going to happen at this one? Are we going to get sodium or hydrogen at the cathode? What am I going to get there? Sodium or hydrogen? Guys, cathodes. Which do I get at the cathode? Sodium or hydrogen? Anyone? Yeah, hydrogen. Even though normally we do it with a big H, but that's okay. Okay, so what's going to happen at the cathode is this. H plus 2H plus 2 electrons is going to give me H2. Yes? Now, so the answer must be this one, mustn't it? Yes? Now, Amy and Audney are complaining. They're saying, well, what's going on here? Okay? Now, well done, Micah. Now, they're saying, what's going on here? Now, this is a bit of an annoying thing, okay? And it does come up sometimes, but it doesn't come often. If it's dilute aqueous sodium chloride, there are more OH minus ions than Cl minus ions. So if it's dilute, believe it or not, you get the OH minus ion discharging. Okay, now I honestly don't think I mentioned that in class. It was something I didn't want to get into, but now we're doing revision, we have to. Okay, so I'm glad it's come up, even though it's a pain. When it dilutes, we get this. Okay, that's why, believe it or not, that they haven't given you any chloride ions here because they don't want to over confuse you. So when it's dilute, we get that one. Is that all right, Audney and Amy? I didn't purposely do it in class.